This conference will now be recorded.
Hey, first of all, good morning and thanks for joining. So the session will go for around 30 to 40 minutes, where I'll just try to explain a couple of things for the agenda today, where we'll basically understand when we say DevOps, what exactly is an organization looking at based on the current trend in the market, and then when you go to a job, right, or when you're trying to apply to a job in the market currently, what are the different kinds of profiles that we have in DevOps, which is another thing that we need to understand, because it's not just about tools. By learning, you will be able to apply. So that's where I'll also talk about what are the different roles, and finally, for getting into an organization on any particular profile, so what will be our career roadmap, or how is that basically you would be able to work towards a DevOps engineer profile. So that is where I'll walk you through all of them. So pretty much, if there's any questions, just give me a couple of minutes so that once we finish this, then I'll be opening it for the question and answers. Okay. So that's the pretty much agenda. So we'll talk about latest trends in DevOps and what exactly organization is looking at, and what are the different profiles that we have, and how do you convert your profile into more of a DevOps profile, and how is that you can apply for all this. Okay, so that's the major concern what many people had. So that's what we would be going through today. But if there's any question specifically on any tools or process, feel free to ask at the end so that we can discuss. Okay, and I'll just request everyone to be on mute for some time so that if anyone wants to listen to this recording later, you can just go through. Yep, I appreciate that. Okay, thank you. So anyway, before we get started, my name is Adam, and I'd be the trainer for all most of the sessions. Okay, can everyone please go on mute? Okay, thank you. Yeah, just to introduce myself, my name is Adam, and yep, I'd be the trainer for the sessions. And what is that we have to learn, right? Now, as I said, before we just start with DevOps. Now, we been hearing this word called DevOps in a couple of years, and everyone has this question that what exactly it is. Now, before we start talking about that, let's first understand. Now, if you take an IT organization or a software company, now their deliverable would be a little different. Maybe they are into a product-based company or a service-based company. Now, what is that as an organization that they are trying to, get as a business goal at the end of the year, right? Now, that is where now each of the organization, the team or the organization goal, what that, yeah, can everyone go on mute? Okay. So how do we make sure that as an organization, whatever that you're delivering, how quickly can you deliver, right? So just think about certain things like you go to Flipkart or Facebook or LinkedIn. Do you expect if there is a delay, or if you're doing some online shopping, what happens that when the shopping list gets loaded very late, or you are expecting for a product but that's not being populated? So that is when whatever the kind of product or service that an organization is trying to deliver, they want to make sure that they are doing it at a faster pace, right? So that is where speed comes into the organization's goal. Now, when we talk about speed, now, in order to help an organization to deliver things faster, because there will be a lot of requirement, now whatever the work that they are doing and the infrastructure which they are using should be scalable, right? Now, for example, assume that I have a product which I was delivering it to 100 customers. Now, suddenly, because of my market, I see that there are 1,000 customers who just want to access my application. How do I make sure that my current infrastructure is completely scalable to help me deliver whatever that I have to do for the 1,000 customers in a faster rate? So that is where it's not just about working faster, but we also have to make sure in order to get the things done, which is your development and testing and deploying, how do we make sure that our infrastructure is completely scalable so that for just an example that for 100 customers, if I had 10 machines, now if for 1,000 customers, if I need, let's say 100 machines, how do I get that 100 machines, the network, the storage, right? Everything in a given time, which I can easily scale. So scale means how can I expand my infrastructure? That is what an organization is looking at. And then when we are working on all this, we also have to focus on how secure that our application or our product is, right? Just because we want to give everything faster, it doesn't mean that it should not be secured, right? So Facebook, let's say, LinkedIn, let's say, they are doing so many changes day by day. Now, just because they are delivering it so faster, if they are giving a product where it has a lot of issues wherein the security is not good, right? Will you be happy where your account gets hacked by someone else in Facebook or LinkedIn? Now that's where they need to make sure that whatever that we are delivering faster, the quality and the security of it is very, very important. And finally, in order to get all these things done, we don't need people to sit and do the work manually, because when more and more people is being involved, it takes more time and that incurs more of cost, right? So that is where the operation or the production cost will be quite higher. And that is the most important requirement where in an organization, they want to reduce the cost for which they expect everything to be automated. So that is where a single person would be able to do multiple tasks within a short time. Now, this is what an organization goal is. Now, keeping this as their requirement, now what an organization is doing or what organizations are doing nowadays is they are moving away with the traditional method of working, wherein earlier, we used to have a developer whose interest or work will be only on doing development. There will be a QA engineer who will be doing only testing. There will be a support engineer who will just take care of some application. Or there will be an administrator who will just take care of a machine. But now, when an organization's business goal is changing, now in order for an organization to help achieve this, it is becoming essential that every one of us have to start focusing towards how do we automate those work. Okay, so that is the concept of DevOps. So the principle of DevOps lies between this. So now each and every one of us have to think, how can I do my work faster and how can I do much more things in a better way by automating? Now, this is where it's not about tools, it is more about adding the roles or responsibilities on top of your current work. Okay, which is very simple what an organization is looking at, and that is what DevOps is all about. So DevOps, as it says, rather than doing your traditional work of only development or testing or application management or database management or administration, you also have to take additional work for which you need to know how to automate and what is that you can do it faster. Okay, so that's the whole concept where an organization will also be beneficial, because rather than just calling as a system admin, if you can take care of the database, the network, as well as the administration, then you are helping an organization, because you are doing automation, you are trying to reduce the work which was doing by 3 people and the time that has been taken, which is where company gets benefited, right? And the same way, if you are a QA engineer, rather than just doing testing, you have to think about how can you set up your own environment which is needed, and how do you do your own deployment, start the application, and then do the automation for the testing. By this way, there is a lot of effort that has been saved, and for which you should be knowing what kind of automation that we have to do. So this is what ideally organizations are moving towards. Okay, so let's not worry about the terminologies or the word where they call it as DevOps, NoOps, CloudOps. Now, the base for all of them is these. Okay, so the question is, it's all about how do we make sure that we fit into the organization need. Okay, so that means how do we make sure that each one of us can take additional responsibilities which is beyond our day-to-day work, and how do we focus on automating those work so that we help an organization in delivering faster and ensuring that we scale whatever the business requirement is there. So this is the requirement of what we call it as DevOps. So DevOps is more of a culture. Okay, it's not about tools. So the culture is, okay, in addition to your day-to-day activity, rather than just doing it manually, automate it. And when you automate it, can you start taking up additional tasks? That's what DevOps is about. Okay. Now, internally, when we say these are the goals for the DevOps, now how do I do this automation? Because the next question comes back is, okay, I am a QA guy, or I'm a dev guy, or I'm an administrator. What is that I can automate? Which is what you need to understand. Okay, so that is what we call it as the goals of the DevOps or the principles of DevOps. So what DevOps says is, in a project or in a product life cycle, right from gathering the requirement to developing, testing, deploying, and maintaining, there will be a lot of areas where you can think of doing automation. Okay, so in that way, what and all can you automate? And to automate, what kind of best practices that you have to implement, and what are the tools involved in it? So that's where the point, as a DevOps engineer, that you should be knowing. So who can be a DevOps engineer? There is no constraint. Okay, okay, there's a lot of background noise. I'm going to mute everyone. So the question here is, now when I was saying about automation, so if you think what is that I can automate, then you have to understand that in your day-to-day activity, there are certain things that has been done before your work, and there are certain things which is done after your work, right? Like if you're a developer, now you write the code, but after that, there are so many things which will happen until it gets the product delivered to the customer. Same way, if you are a development, sorry, QA, now before you test, there should be someone like a developer who should write the code, and then you will test. And what after you test? There will be someone else who will take care of deploying it into a production place, which will access by customer. Same way, if you're more as an administrator or a support engineer, there are people who will work before you, give the work to you, and you finish and give it on to the next one. So that way, if we see, there are automation that we can do from the beginning to end of a product that we are going to deliver. And this is when in DevOps, as of now, there are almost like 8 to 9 best principles, or what we call it as best practices involved. And each one of them focuses on a particular area which you can automate. Okay, so for any one of us who wants to become a DevOps engineer, it is necessary that we should be knowing all these, so that when an opportunity is given to you, you would be able to say that, yes, I know this concept and I know how to automate. And in this, there are a couple of tools, and I'm aware of one of the tool to automate. So that is how, by being aware of all the principles of the DevOps, you will be able to think about automating. Because automating is not just, okay, you give a command or a tool, you will automate. You should first know what is the problem and how to solve the problem. And for that, what is the best practice or the principle that we have to apply? And then what kind of tool that you have to use. Okay, so that is how the approach should be. Now, in that way, in DevOps, the very first principle or the goal that we need to understand is continuous development. So what is continuous development in brief? So continuous development is not just about writing code. Writing code. But what happens is, when you go to an organization, a team would be working on multiple products or projects, right? So in that way, how do we assist the entire development team to make sure when there are parallel releases or parallel requirements coming, you should be able to easily develop and easily give it to the QA. So that concept is what we call it as continuous development. And how do we achieve? So for this, it is not about writing a program, but where do you store that file? How do you make sure that when a person is writing a code, the other person in the team can also write the code in parallel? Now, which is where the concept of version controlling system comes into the picture. Now, version controlling system, when I say, it is nothing but a tool in which we will ask the users to store and maintain the complete history of what you are modifying. Okay. Now, being said this, every organization now, if you're developing something, we insist that instead of storing the file somewhere, you need to use this version controlling system or tool and try to store. Now, along with it, you also need to follow some development principles like agile methodology. So that is where DevOps says in order to implement continuous development, you need to use some version controlling system and you also have to follow the agile methodology. Okay, so this is just about some process where what you are doing daily, how much you have completed, what you will be doing next. So all those things can be easily tracked using agile. Now, along with it, whatever the code that we are going to write, we are going to use some version controlling system or a tool and store. Now, in this, there is another question that you might think, okay, whenever I say code and development, so are you talking only about a developer? So does this principle fit only to developers? No, it's not like that, because developers are the ones who write code daily as part of their work. But on the other side, if you look, when we have to automate, whether you are a QA, okay, am I audible to everyone?
Yep.
Yes, go ahead.
Yes.
No. Okay, sorry for that. Yeah, if there's a network issue, please reconnect. So what I'm saying here is when you have to do some automation, what happens is you also have to write some kind of small scripts, or you might have to develop some small tool, or you have to develop some small configuration file. Now, all of them are text file. Okay, so code is not always program. Code can be a program, or it can be a script, or it can be simple a configuration file. Now, when you are going to write all those things to automate your development work or testing work or support work or administration work, then where are you going to store? Because in your team now, along with you, there will be many others also have to develop. So start understanding this word. There is a difference between writing a code and developing a script. So for your day-to-day automation, you also have to now start developing some kind of script. Maybe it could be a PowerShell or a shell script or a Python script or some text files that you have to develop. Now, where are you going to store? So that is when you also have to start using the same concept of continuous development, in which you should be adapting to this tool. Now, the usage might vary because you might not be using it like every day, but whenever that is needed, you're still going to follow. Whereas if you're a developer who's writing a program for a project, then they might be using it daily. So that's the difference. But regardless of the use case, you need to understand that every day or whenever it is needed, you have to adapt to this. So that is where, as we start storing all our code into a place, it will be easy for us to develop whatever that we are writing, and it will be easy for us to use it for further areas of testing or deployment. And we also have to follow the concepts of using an agile methodology, because agile is a way where you can easily track how much of time that you need to complete a task and where are you currently. So that is how, as soon as you start going into a company now, everyone starts talking about working in an agile way. So agile is not only for a developer or a QA team, it's for every one of us to be part of a software team and ensure how we can develop everything faster, whether it could be a product or it could be a script or a tool or some document needed for your day-to-day work. Now, what after this? The next one is infrastructure as a code. Now, this is one of the recent principle that has been added into DevOps. And what happened here? So as I was saying earlier, so far, if you wanted to do some work, you will just focus only on your work like testing or supporting work or deploying. But for that, if a machine has to be created, a database has to be created, a network has to be set up, you always go back to a separate team or a separate set of people to whom you will request wait for everything to get done, right? And this is where in DevOps, we also are expected that if you have the knowledge, you can also go ahead and automate the entire infrastructure that is needed. Now, when I say infrastructure, it's not the entire data center that is needed, but for your work to do. Now, assume you are taking care of automating a deployment for a product. Then, for that, what machine is needed? Okay, how much of database or storage is needed? What kind of network is needed? You should be able to create it by yourself. Now, are you doing testing? For your testing, if you want to run an application, if there is a machine, you should be able to create it by yourself. Same way, are you doing a development? For your development, if you feel that you need some services or some applications and some machine, you should be able to just create the infrastructure and start running everything inside. So that is how infrastructure as a code is a concept where whether you are using your physical machines or virtual machines or cloud machines, you should be able to know how to automate the process of creating an infrastructure for your day-to-day purpose. Now, for that, there are a lot of tools again available, but understand the expectation the companies are having is given a chance, can you do that? Because now, whether I'm doing some development work or testing work, I don't have to wait by asking someone else to help me to create a machine and then start doing the work. Because even for a 10 minutes work, you would be spending even hours together or days to get a machine. So that is where by adapting to the concept called infrastructure as a code, you should be able to develop some small code using which you will be able to generate your own infrastructure. Okay. Now, once again, this is needed by everyone because as a developer, you might think you need only one machine. Same way for a QA, you might think of one or two machines. Maybe if you're a support engineer, you might think of 4 machines or 5 machines. But if you're an administrator, then you might think of hundreds of machines, right? So the use cases will be different, but end of the day, for all of us in DevOps, we need to think of how do I automate? So that is where infrastructure as a code is not something only administrators should look. Now, just like how I said, the continuous development is majorly needed for developers, but still all of us will try to write some code and maintain. The same way, in the infrastructure as a code, for administrators, you will be using day in and day out completely because your work will be majorly on the administration side. However, if you look at others, like so far, if you're being a developer or a QA or a support engineer or a database or a storage guy, for your day-to-day activity to automate it, you should be able to implement it. So that is how this is again needed by everyone, but the amount of infrastructure that you're going to create will vary. Depending on that, you will be using it on a moderate basis. So if your work is more towards infrastructure maintenance, then you will be using this daily. But if you need an infrastructure for any of your development or testing, still you need to use it whenever you want. Now, why do we need it? Because even if it is a small machine creation, if it is going to take 1 hour, but by automating, if I can create the same thing in less than 5 minutes, then I am saving so much of time. So this is how everyone, when they save time by doing automation on an organization, you can deliver things faster and it is going to be cost effective. Okay, so that's the reason automation has to be taught in every area. Now, once we talk about infrastructure, the next one that we have is configuration. And that is where the next principle what we have is configuration as a code. So now again, you might think, what is this configuration? So think of this. You are a developer. Now using infrastructure as a code or a tool, you developed a script or infrastructure that you need. For example, let's say I wanted 2 machines for my development or testing. Now, by using this concept called infrastructure as a code, I was able to create 2 machines in less than 10 seconds. Okay, but what happens after that? Now, within the machine, you need to install some software, or you need to create some folder, you need to give some permissions to some user, you need to run some application or install some package. Now, these are the work what you do, which is what we technically call it as configuring the machine, right? Because if you try to, let's say, run a Java application, for that you need to make sure that there is JDK installed and there are some particular libraries available. Now for QA, if you need to access and do some testing, now before running your application, there should be some packages available. There should be some software tools which is configured. You need a particular folder available, and there should be some user exactly created. Now these things are what we call it as configuration. Same way, if you are an administrator, then the usage will be little high. So you need to make sure that a list of users are already added to the machine. You have some pre-packages installed into the machine. There are some services always running, or you might have to think of taking frequent backups of the machine, update certificates when there are hundreds of machines, right? So these are the activity which we call it as configuring a machine. Now this is where infrastructure as a code is about how do you create that machine, that is the infrastructure. But after you create, how do you make sure that the machine is configured so that you can start using it immediately? And that's where in DevOps the next concept what we have is configuration as a code. So see how many things are needed. So in VCS, you try to write code, whatever you're writing, you're going to store. Whereas in infrastructure as a code, you write a code and again, end of the day, you're going to store it in VCS. But using IAC, you're going to make sure that the infra or the machine that you need is available. But inside the machine, if you want to make sure that whatever that you need is automatically configured, then you're going to use another principle called as configuration as a code. So this is where there are a lot of tools specific to this. So when you start using, you will be configuring the machine. Now, once again, understand depending on the use cases, you will be using these. Because assume in a company, you will not be doing everything, but given a chance, are you going to do? That is the question. And this is when, if someone is giving you a machine, okay, now at least can you automate from there onwards? So assume that I cannot allow you to create a machine in production, but if I create a machine and give it to you using IAC, can you do some automation by yourself where you can configure it, which is where configuration as a code comes in. Okay, but as I'm still telling, so it is not as an individual that everyone should be doing it, but as an organization, we need all those things to happen. So we need to automate the machine creation, and inside the machine, we need to automate the configuration of the machine. Okay, so for any of the work, we will be doing these two as the principle nowadays. Now, what after this? Now, this is where we know how to store the code, how to automate machine creation or infra creation, and we also know how do we automate the configuring of a machine. Now, the next point comes is when a developer is writing his code, how do I make sure as soon as the developer completes this coding, I should be taking that product and giving it to a QA? Because this is where when a developer writes a code, the files will be in a raw format. Okay, so you cannot just take a Java file, whatever he's writing, and ask for testing. Because when you say a product, the product consists of multiple files inside it. So you need to create a single product by combining multiple files. And that's where there is a process called build. Okay, we generally call it as building a software. So you have to convert your hundreds and thousands of Java file into a product, which could be a jar or a var. Now, for that, we need a standard in which we make sure that we are not going to just develop at some point of time and test it at some point of time. Development will happen continuously, but at the same time, I also want to make sure that testing also happens continuously. Now, in order to get both of them facilitated, we will be going through a best practice called what we call it as continuous integration. Okay. So now, what is continuous integration? So continuous integration is a process where what we have to do is make sure whenever a developer writes a code, we automate the process of creating or building a product and trying to immediately give it to QA. Wherein, if needed, we can also automate the process of running the QA or test suits. That concept is what we call it as continuous integration. As it says, you integrate development and testing. So developer writes, immediately the automation should trigger and you should develop a jar, var, RPM, whatever is the deliverable, and you should be able to give it to QA so that they can test it further. Okay. Now, that's the concept. But for implementing it, again, the question comes, who should be doing? Now, this is where anyone can do it. So now, do you know how do you automate this process? Now, this is where whether you are a developer or a QA or an admin, in addition to your existing work, you can also take this responsibility and make sure that the product is developed automatically and whenever we need. So we don't have to wait for someone to create the product and give it to me. Okay, so that's the concept, what we call it as CI. Now, once we say CI, for me, in order to deploy my application, because what is deployment? So assume that you generate a application which could be a standalone or a web application. Now, in order for you to run it, you just don't need one machine, because think of an organization like Facebook or LinkedIn or Google. Do you think they have only one application which is running in one machine, right? That will not happen, because there will be so much of load. There is multiple copies of our application should be running, and for that there will be many machines running. So deployment is a process where you take your application and run on whatever the machine that you want and make sure your application is up, so that as a customer you will be able to access. Now, this is where, how do I know and how do I manage when I have hundreds of machine, where to run my application and how to start? Now, that process is what we call it as deployment. So rather than doing this process in a manual way, so in DevOps, we focus on a concept called continuous deployment, where when a cluster of machine, cluster means a group of machine is given to you, you should be able to automatically just run a command and make sure that the application gets created in any one of the machine available, and in that it should be automatically also able to scale. Because right now, let's say I have one copy of my application. Now suddenly 100 customers come, I want to make that one copy as 100 copy. You should be able to do it in matter of seconds, and for that I don't want to go to a machine and run some commands. Instead, with just one command, you should be able to achieve everything automatically. So that process where, how do you make sure that your application is started up in a machine without you telling where to do it, right? So that concept is what we call it as continuous deployment. Now, once again, who can automate it? Any one of us. Now, if you're a QA, rather than waiting for someone to do the deployment, you can also do this automation so that whenever you need, automatically deploy and start taking care of your testing. Or in a simple way, we can integrate the continuous integration with this, so that whenever a developer writes a code, you are going to generate a deliverable. Rather than giving it to QA, you can automatically run this in a environment like a QA environment or a production environment, against which a customer or a QA guy can use it. So that process of automatically running your application into an environment so that someone can use it is what we call it as continuous deployment, or CD, in which the automation, what you're going to focus is, there will be many machines available. In that, you need to do some orchestration, or what we call it as a management, so that you don't have to tell where to run. You just give the information that, hey, I need 100 copies of my application. Where it has to run, how it has to run, should all be automated. So that is the focus of DevOps, on how do you automate that deployment. Okay. Now, when we are talking about CI/CD, so there is another best practice or the principle what we have in DevOps is GitOps. Now this is something new which is coming into the market. Okay. Now here, what is GitOps? Again, I'm just talking about the concepts. So when you're talking about deployment or when you're talking about infrastructure as a code, so you will be developing some kind of files. Maybe you will develop a HCL file here. You will be developing a YAML file here. You will be generating some pipeline file here. Or again, if you're using Kubernetes, you might use some YAML file for CD. Now, end of the day, you are going to store all of them into a version controlling system. So GitOps is a concept where it's not just about writing the code, but write it in such a way so that I don't have to trigger it manually. Because whenever I modify, automatically that should be taken and that should be executed against a particular machine in which you can create the infrastructure or you can do a continuous integration or you can deploy it. So that logic is what we call it as GitOps. Now, GitOps means if you're writing your code, store it in a tool called Git, and automatically, whenever you store, it should be taken and executed immediately. So that concept of automating those is called as GitOps. GitOps doesn't talk only for deployment. You can use the GitOps to even run your infrastructure as a code or run your configuration as a code or run your deployment. So the whole logic here in GitOps is write code and store it in Git, where whenever I check in a new file or do a new change, I should be automatically able to trigger some automation. Okay, so that's how continuously you will be able to deliver all this using this principle called DevOps. And this is where whatever that we are going to use for our day-to-day work, it is needed. Okay, then what is the next principle in DevOps? See, when we are doing all these kind of automation, now there will be a lot of applications and machines or services that you will be taking care. Now, it is equally important for us to also to make sure that the machines and applications that we are using for all this should also be running fine. And that is where every day it is our responsibility to monitor and make sure that those applications and services are running fine. For example, if you are using Git for VCS, there will be a tool like GitLab. So you need to make sure that GitLab is running fine. If you are using CI and if you are using Jenkins, for example, you need to make sure that Jenkins is running. And further, if you are using Kubernetes or Docker, you need to make sure that the Kubernetes cluster is running fine. And between, if there are some applications needed, like SonarQube or Artifactory or Nexus, whatever the tools that you're using, right? Even for your testing, if you're using Selenium, then you need to know that those applications or the machines are running fine. So that is where in DevOps, the principle of continuous monitoring is something where you need to make sure that whatever the application and machine that you are owning should be monitored, and anytime if there is a problem in it, you should be fixing it immediately. Okay. Now, this is for someone where we are using for our day-to-day work. The same way, if you are, more towards support, then it is also equally important for you to make sure for your support work, what are those machines and applications running? So you should also monitor them. So that is where it depends on what you are monitoring, because at the end of the day, in DevOps, we should make sure whatever that machine or application we are owning, it is our responsible to monitor. So that is where using different set of tools based on what you want to monitor, you need to set up a continuous monitoring process which will let you know at any time if a machine or an application is not working, so that you can immediately take an action and fix it. Okay, so that is where it's quite important for us to be proactive and try to provide a fix anytime if there is a problem. So this is another principle. Now, when we are talking all about this, it is also equally important to take care of the logs, because when you say monitoring, how do I monitor my application? Because let's assume you are a QA, right? or you are a application support engineer. If suddenly a machine is not working or an application is not working, to debug, you need to know the logs, right? Now, where are the logs available? Now, so far, what do? We always send a mail to some admin and say that, hey, can you get me some log? I want to see. Now, that is where, when in the DevOps, if we are going to own a machine or an application and we are monitoring, we also have to make sure that for those applications and machines, we should be able to handle the log management, so that for you to debug or for anyone else in the team to debug, you need to have the mechanism of managing the logs, right? Especially if you are taking care of deployment or monitoring, you should know how that works. So that is where it is also our responsibility to take care of managing logs. And for that, there will be different tools available. Again, depending on what type of logs, what application or machine that you want to manage, you should also take care of log management. So this is also one of the principle in DevOps that we have to focus. Okay. And finally comes the point what is called as DevSecOps. Okay. So what is this DevSecOps? So we are talking about so many machines. We are talking about so many applications. Now we need to ensure that there is a security available everywhere, because in the first slide I told you, as an organization, the important point was security. So what are the levels at which security should be there? Security has to be implemented at every phase of a software lifecycle. That is what DevOps talks. For example, if a person is writing a code, you need to make sure that whether the code that he is writing is not having much of vulnerability or issues, right? Because it is not only while you are accessing, but while writing the code itself, you should be able to do. So that is when, as part of CI process, what you can do, whenever a developer writes a code, you can scan the code and ensure whether there is any vulnerability or is there any issues in the code before even giving to QA. So that is where we have to adapt the security in every phase. So when you do CI, you will be implementing the best practice, which is where you will be using certain tools like code coverage or code analysis tools to make sure that the code is free from vulnerability. And deployment. So when I'm going to deploy, you are going to use image, which is what nowadays completely the industry is using, like a Docker image. Now you also have to scan them, right? Or if you're going to use some machine, you're also going to scan that machine or the OS and make sure it is hardened. So we use this word called as OS hardening or application hardening. So what it means is, there is any vulnerability or a files available in that which is not according to the organization, we should be able to remove them. This is where security can also be implemented at a deployment level, where you will scan your images before you run it in your production. And not just this. So whether you're accessing your monitoring, whether you're accessing your application log, now there are many tools available. So in all the tools, you need to create some kind of role and then tell who should be able to log into that machine, who should not be able to log into that machine. That is also your DevSecOps. For example, if you say Kubernetes, in Kubernetes, it is not that anyone can go to a machine and execute kubectl command. So you can have a control using a process called role-based access, which is what we call it as RBAC. Okay. So using that, I can have a security enabled wherein I will tell who should do that, who should not do. Same way, if I'm going to a continuous integration process, it is not like a tool like Jenkins where everyone will access. Now, if you have a tool, you can tell who should access, who should not access. The same way, when you come back to even a version controlling tool like Git or GitLab, you should be having a control on who should modify, who should not be modifying. So that is where in all of this principle, it's not just about using a tool, but you should also think about enabling a security at every layer, which is what the final thing which DevSecOps talks about. Okay. So now, as an organization, if you see from beginning to end, it is needed for an organization to implement all these best practices together. So only then you will be able to automate development, then automate the testing, automate the deployment, and for that, whatever the infrastructure creation will be automated, configuring them will be automated, and how do you monitor them will be automated. And you also make sure that there is a security involved at all of this step. So now, for an organization, all these best practices are needed. Okay, so now let's not worry about who's going to work, but if you understand, as an organization, all these principles is what needed to implement the DevOps culture. And this is where the next thing comes is the tools. Now there are plenty of tools in each of the area, but let's talk some of the popular tools. So if you talk about the continuous development, so you have the agile methodology, and along with the agile methodology, so we have tools like Git and GitLab. Now this is where what you need to know is it is not just Git, because Git is only the client side. There is another server side of the tool, which is where you will be using tools like GitLab or Bitbucket. Now, using the combination of Agile and these tools, we will be able to set up continuous development. Okay. And then for continuous integration, there are many tools again available in the market, but one of the popular tool is Jenkins. But Jenkins alone is not here, because now Jenkins is going to use two different tools interconnected, like Maven for doing the build, and now it can use JFrog or Nexus to store the artifact. And if you're implementing the DevSecOps, then it will be internally connecting to tools like SonarQube or Chicago. So that is how CI is a process of combining all these tools to ensure that whenever a developer writes a code, you're going to give a deliverable or an artifact which is exactly free from vulnerability. Okay. Now, when we talk about deployment, the latest trend of what we are going to deploy is using containers. So rather than running your application directly, you're going to put it inside an image and start creating containers. And this is where the whole concept of Docker comes into the picture. But once again, in Docker, there are multiple things that you need to know, wherein if a image is given, how do you generate your own image? Or if image is given to you, from that how do you create a container? Okay, so that is how an artifact is nothing but a deliverable or that particular product that you are going to run and get your application up and running. So anything like that is called as an artifact. So generally your jar or var or an rpm or a zip file, that is what we call it as artifact. Okay, and then when we talk about GitOps, now this is where if you are going to use Docker, then you're not going to run your Docker images directly into your Kubernetes cluster, but you're going to generate something called as Helm package. And on top of that, there will be certain tools. Now earlier, even though this GitOps was there in the market, it was not popular. But nowadays, if you see, instead of using the traditional tool like Spinnaker or Harness, people are moving towards lightweight tools, which is easily usable by everyone. So this is where tools like Flux or Argo CD is what being popular in GitOps. So in GitOps, you need to learn things like Helm chart and a tool like Argo CD. Okay, and then if you want to manage the orchestration deployment, then comes Kubernetes, because earlier Swarm was popular to run your Docker and Helm chart, but now if you see, it's more about Kubernetes is what is the preferable orchestration tool, wherein you can create a cluster of machines and run your Docker image on that. However, we need to monitor them and we need to take care of log. So that is where if you're taking care of your log management, then for Kubernetes, one of the preferable set of tools that we use is EFK, Elasticsearch, Fluentd, and Kibana. So that's a combination using which you will do the log management of your application running inside Kubernetes. And then going back to infrastructure as a code, so there are many tools available in the market, but since there are multiple cloud coming into a picture, so industry is focusing about using one tool which can connect to all the cloud, which is what we call it as cloud agnostic, and that's where Terraform is popular. Okay, and for configuration as a code, once again, there are many tools available in the market like Chef or Puppet, but going towards a way where it is easy to maintain and write, Ansible is the tool which is quite popular nowadays for doing the configuration management. Okay. And finally, to do a monitoring, again, we had a lot of tools. Like people talk a lot about Nagios. Now, Nagios is not going to help you to monitor applications, right? That is where you need a mechanism in which you are going to monitor applications like what you are using here and the machines in which it is running, which will be on a cloud environment, because we are moving completely our infrastructure from our physical infrastructure to more of a cloud infrastructure. So that is where, as a cloud native solution, all the tools what you use is important, because all the tools that I'm mentioning, for example, Terraform, Argo CD, EFK, all these things are best tools or most popular tools in the cloud native solution. And in that way, for monitoring nowadays in the cloud native solution, you would be having Prometheus and Grafana. Okay. Now, all of them, where will it run? You need to run it on a cloud, which is something like AWS or Azure. This is where, for us, we need to now be aware of what are the best practices that is available in DevOps. Okay. So, which is what we just now saw, those 8 or 9 best practices. Okay. So far, this is what everyone might have been telling. But what is that now you need to know is, okay, you are working as a QA, a developer, or a system admin, database admin, or you are working as a support engineer. And what did I tell? In terms of DevOps, there are around 8 to 9 best principles, or what we call it as the more of pillars of DevOps. And in that, there are some tools and processes. Okay. Now comes the next question is, how is that will fit into your work, or what are the things that I have to learn? Because when you go to a company, just by learning these tools, will it be sufficient for you? No. Because in an organization, this is where it's very important that you need to understand there are different profiles in DevOps. Because when you take an organization, DevOps is an organization level of automation that you do. It is not team specific. Okay. Now that is where in a company, now usually you can divide them into two groups. One is the product group, or what we generally call it as the engineering group. And in this, you will have people like developer, QA, a release engineer, or a program manager, or let's talk about a person who's doing some support. Now, all those who are working towards releasing a product will be in one group. However, there will be another group, which is what we call it as administration group or operations group. And there, your focus will be heavily on to the system administration or networking. But in DevOps, it is not mandatory that in a company, you will be working on all the best practices that I was talking about earlier. Now, this is where, depending on the nature of the problem that you are going to solve, you will be working towards automating the release work, or you will be focusing towards taking care of the administration of your infra, which is going to be on cloud. And that's where cloud operations comes into the picture. Okay. So you need to now understand, if you are going to a company, and in that company, if the expectation of you is to help to release a product faster, then they will be asking you more about the application side and the tools related to it. And there will be little less work that you will be doing on the operations and the infrastructure. However, if you go to an organization where you are joining the operations team, and if the expectation of you is to solve the infrastructure related issue, then you will be working heavily on doing the operations and the tools related to the infrastructure. And there will be a little lesser, work that you will be doing on the release side. For example, if you go to the release automation side of a company, they will be asking you more towards CI, CD, continuous development, monitoring, and monitoring your application and taking care of the log management. And there will be little bit of work. When I say little, it doesn't mean that no work, but let's assume out of 100%, the amount of work that you will be doing on operations or on the infrastructure will be maybe like 10 to 20%, but still it is needed. But when you come to the other side, when you go to a company and you are going to support for the infrastructure, this is where they call themselves as cloud engineer or AWS engineer or Azure engineer. Even then, you are working in the culture of DevOps. But understand, your work is going to be 70% or 80% on the cloud, and there will be a little bit of work on CI/CD. So then your focus will be heavily on taking care of the infrastructure, then using Terraform or Ansible or monitoring your data center. Log management of your data center will be very much needed. So that is where nowadays what is happening is it's a combination of the tools and different process. So by this, you need to understand when you are trying to prepare yourself to get into this DevOps culture, which role are you going to fit in the beginning? Because it's purely about the skill set and knowledge what you are going to have. So if you are going to learn only the tools and processes and not much into the cloud administration side or operation side, then you can fit into those companies who look for release automation. But if you are focusing only on taking care of the infrastructure and monitoring those infrastructure, then you will be fitting into cloud ops. Now, there are companies nowadays who have started focusing on both of them because they will be asking 50% of release automation and 50% of cloud ops. So this is where you need to understand where are you right now, and for you to get into DevOps, what is the roadmap or what we generally call it as the career path that you have to take. So you need to know what to learn first, what to learn second, and then move, because you can learn the release side tools, you can also learn the cloud operation, then your profile will be quite big so that you can fit into any organization. Now this is where biggest problem happens is people just learn without knowing one side of it. Like for example, you directly go and learn only AWS or Azure, but when you apply, still for that organization, that profile in DevOps, they will also be asking you Kubernetes, Docker, and infrastructure as a code like Terraform or Ansible. But the ratio of the work or amount of the work varies. Same way, people go ahead and start taking interviews for an organization where if you are focusing only on the tools like Docker, Kubernetes, yes, Jenkins, it is sufficient. But in that also, there is some day-to-day work that you have to do in operation for which they will ask you, do you know the concepts of cloud? That is where when you're working on the release automation, you need to know the cloud for automation level. Okay. Whereas if you're coming to the cloud operation, you need to know the cloud like AWS or Azure as an administrator. The same way, when you're focusing on cloud operations, you will be using the tools, but only for your infrastructure. So that is when now the last question comes is, okay, what is that I should learn then? So how do I fit into this position or this position? Or if I learn both, then the opportunities for you will be still wide open so that you can fit into any company regardless of what kind of profile or what kind of tools they will be giving. Because remember, you will not going to work on each and every concept and tool that we saw, but you should be having the ability to work given a chance. So that is how in an interview they will be asking you so many questions, and they will be trying to understand whether do you know all those best practices that we were talking in DevOps is something which you know, so that I can give you an opportunity. And that is the whole reason why DevOps engineers are being paid heavily. Okay. So finally, with this information, how do you become a DevOps engineer? Okay, so you can group it into three categories. So the first one, what we call it as foundation. Now, this is where, regardless of whatever work that you are doing currently, to get started, you need to know the foundation, which is you should be good in Linux, not as a system admin, but at least from a person who can debug and triage your day-to-day activity, right? Just like you're using your laptop, you should know how to do the simple basic management of your laptop. The same way, when you're saying, I can use or I know the concepts of infrastructure automation, configuration automation, CI, CD, so many things, then obviously it is expected that if there is some small issues, you should be able to debug by yourself. So for that, you should be having a good control and basic knowledge on Linux. And then it is not that a single tool can solve all the problem. So sometimes you might have to write some small scripts. This is where people mistake saying, oh, for development, do I need to know coding knowledge? Coding is different, programming is different. Because when you use tool like Terraform, Ansible, Kubernetes, Jenkins, everywhere you are going to write some code, which is not a program. It is more of some syntax that you're going to write, which is simple. And that is where, to manage all those things, you need to know some basic scripting. Once again, if you're already a developer, you can know Java, Python, Go language, that is good. But if you're not from that background, then start with something simple like PowerShell or shell scripting, so that at least given a small task, you should be able to automate, right? So that is where it is quite necessary that if you know scripting, it will be helpful for you to do some automation. And then when I was talking about version controlling, now, regardless of, once again, whether you are a dev, QA, or a support engineer, in your day-to-day work, you should definitely write some script or some file. And where are you going to store? You should be knowing the basics of version controlling system like Git. Okay. And the same way, the build management. The build management is all about, if I give a file like a Java file, how do you convert it into a jar or a var? So this much of basic is what everyone needs to know first. Okay. So once you know this, then you will be able to start learning the second step, which is called as essentials or the DevOps requirements. Now, this is where you are going to focus on all of those best practices and you're going to learn tools specifically into it. Because to do all these things internally, you will be using Linux, and whenever it is needed, you are going to write some script. And as soon as you write some files, where are you going to store? You're going to store it into some system like Git. So that is where it is quite necessary that once you finish this, you should be starting up with the essentials. However, it is not mandatory that only when you complete this you should be coming, but out of that, the only thing what you need to know is version controlling. So at least if you learn this, all the other things should be easy for you to get started. Okay. Now, what will happen after this? Because when you're learning this concepts, and this is where when you learn tools like Jenkins, Docker, Kubernetes, Helm chart, Elasticsearch, Fluentd, Kibana, Prometheus, all those things. Now, if you are going to run all these, you need to have a basic knowledge of cloud. So that is where, take any one of the cloud and start learning it, not from an administrator level, but more from an automation level. So when you learn essential, you should also be learning the basics of cloud. And only when you finish this, then you can get into the cloud operations, where you can choose a particular cloud of your interest, and in this you can learn more from a certification level or from a particular operation level in deeper. Okay. Because for example, for me to do a deployment, I need a Kubernetes cluster. So in the DevOps Essential for orchestration, if you just know how to create a cluster and run your Kubernetes YAML files, or what we call it as manifest files, that is sufficient. But if you're going to cloud operations, then you need to start thinking about, how do I do auto scaling of my cluster? How do I make sure high availability of the cluster? How do I make sure security of the cluster? Right? So like that, your focus will be completely into the operations on the cloud. So that is where, after this, based on your interest, you can choose a cloud and then start learning into the administration side. So this way, as you move to the market, once you know all these things, your profile will be suitable to any organization, because maybe they can give 50% of essentials, 50% of cloud ops, you will fit. Or if they're giving you 80% of these essentials and 20% of cloud ops, you will still fit. So that is where now you need to go back and try to understand, where do you fit in, and where do you want to start, and how do you want to go? Because it is not possible that you can learn everything in one shot, right? This is where people fool around saying one course or one set of tools that you can learn. No, it takes time. So that you need to first understand, okay, let me understand by learning the essentials first, and that is my goal for 2 months or 3 months. And then let me learn cloud ops. Now in that also, which one you can choose, and then you can spend another 2 months or 3 months. Suppose if you feel that you are going abroad and you want to learn multiple cloud, then you have to spend another 2 months or 3 months on each one of them, and that's how you can get certified and keep moving. Okay, so this is the whole way on how you can convert yourself to become a DevOps engineer. All right. And finally, so for those who have come here for this demo, so we do have these as a separate course, so that you need to understand if you are coming from a background which is not system administration or not or non-administration background, then you need to fit into the first essential parts, wherein you will be learning all the DevOps concepts and tools and learn the automation side of the cloud like AWS. And then you should jump into the cloud operations, where if you take AWS or Azure, you should be able to go deeper onto it. So as a course, what we do now, we make sure that there will be a daily recordings of all the live classes that we take. And when we teach, it's going to be scenario based, so that, like how I'm telling, we are not going to jump into the tool and just say, oh, this tool is needed, run this. Now you should need to know first why that tool is needed, what made you to use that tool, what problem that you're trying to solve. So that's how it is going to be completely a scenario based coaching. And we are not going to stop only with that. We are going to take lots and lots of projects, and we will be giving you real time use cases to make you think how everything is interconnected. And finally, for all these things, there's going to be like every day 2 hours of session, but it's not going to be easy for you to recall. So along with the video, we will be giving you those class notes, documents, plus whatever the projects that we try to show you, everything will be sent to you, so that you don't waste much of the time in repeating. So you just take it, quickly able to reproduce it. Okay. And finally comes the point where we don't want to stop only that. Now we want to specifically care for you, where we should be able to help you now with all these things that you know. How do you change your profile? How do you write your CV? What kind of projects that you should put? How you should explain? And then when you talk to an interviewer or someone, you should know how you will be able to clear the interview. So that is where we will be doing a specific mentoring as we go through. The more and more you practice and come back to us, we will be giving you those mentorship and career guidance, using which you will be able to easily convert into a DevOps engineer. Now, the path of becoming a DevOps engineer doesn't happen in 1 month or 2 months. It is easy, but it takes time depending on how you prepare and what are the steps that you have to go through. All right. So that's the whole point, where we wanted to first make you understand on what exactly we wanted to do. And again, if you talk specifically on this master program, what we want to do for 8 weeks, these are the set of tools that we want to take, and in which now the biggest question that comes is, how can I do all those things in 8 weeks? Practically no one can do. That is where what we want to do is, we want to give the foundation videos, that whatever we are talking about, as a self-learning videos. So it's going to be around 30-40 hours of videos, where you can do it as a self-learning. Okay. And what we are going to do now is, we are going to take the essential concepts of DevOps, and this is where we are going to go through the live class, in which we will be learning all these latest tools and concepts. So the only thing what I would expect you from now onwards is that go back and start looking into this side by side, in which the most important one I want you to look at is Git. So if you can prepare Git by the time we start the batch in a week, so you will be able to start jumping into this directly. And side by side, when you have time, you should start practicing. So this is how, within a matter of 2 months, we will be able to make sure that you have everything which is needed, wherein without wasting much of the time. Because I believe personally that just by giving for namesake, all the tools will not work out. So that is the reason, very clearly, we want to make sure that you get a lot of videos to do self-learning, and we help you in those important areas which is more latest and you need more guidance. And that is how we will be able to spend more time on projects, and we will be able to give you those notes and assignments and help you to achieve a goal that is needed. And this is how you will be completing the essential. And post this, If someone is interested, then we will be talking about the cloud ops, where we will be talking more about what is that operation, and specifically if you're interested in AWS or Azure. So in that we have to go deeper. But anyway, I'm keeping that aside later, because most of you are going to fit into this, because without completing these two first steps, going into cloud ops will not be of no use for now. Okay, so that's what I had as a point of discussion. But anyway, I'm open to discussion if there's any questions that you have.